Uh, the next topic of discussion is change of order of integration. This particular heading suggests that we need to change the order of integration. Means looking at the example, suppose I am having the variable limits in x. That means they represent the variable y, and y should be integrated first. And the strip which is drawn is a vertical strip parallel to y-axis, and later on the limits of x will appear in the constant form. So all the cases of definite integration, we have the finite quantity or the value as the answer. So in such cases wherein the appearance of the integrand is complicated, or as per the given sequence, means as I said that variable limits will be in the form of x, means they represent y. So accordingly I have to first integrate with respect to y and then with respect to x. So in such cases it will be not possible for us looking at the integrand to do the integration first with respect to y. So if it is not mentioned but still we feel that it is difficult for us to simplify, we will change the order. We will change the order or reverse the order. Means what? We will be first interpreting the region from the given limits, and then instead of vertical strip we prefer horizontal strip, so as the limits of x becomes in form of variable and other pair of limits will become constant. And in that case simplification or the integration becomes very easy. And that is how the process says about change of order of integration. So in a case of Cartesian coordinate system, if we are integrating looking at the problem first with respect to y and then with respect to x, then we, by changing the order of integration, our sequence will be first to integrate with respect to x and then with respect to y. Similarly, in case of polar coordinate, by default always we integrate first with respect to r and then with respect to theta. But if such a example appears or occurs in front of us that we have to change the order in polar coordinate system also, then we will have to first integrate with respect to theta, where theta will be expressed in the form of r, and r will be then convert integrated and the limits will be put as constant, so as to get the finite value or the constant quantity as the answer in a case of change of order of integration. But that is a very rare case, wherein for the case of polar coordinates you will be changing the order of integration. Usually we try to see it that change of order of integration is mostly to be applied for the Cartesian coordinate system. So to evaluate the double integral, we apply change of order of integration for several complicated integrals. Then the change of order of integration means changing the limits of integration. To find the new limits, we draw the rough sketch of the region. Initially, whatever data is provided, we first draw the region, and after drawing the region, we change the limits of integration. If the limits of integration are constant, then order of integration is immaterial, provided the limits of integration are changed accordingly. So whenever the limits are constant, order is not important. But I told you, every time you need to maintain the proper pair limited to a certain variable. So innermost integral, whatever is the differential, the limits will represent that variable. The outermost integral, whatever is the value, it will represent the that limits for the variable. So in the example, integral y is equal to c to d, integral x is equal to a to b, f of xy dx dy. So this is to be integrated first with respect to x, and limits of x are from a to b. Now after changing the order of integration, I will integrate first with respect to y, but limits will be put as c to d and not a to b. So firstly integration is done with respect to y, and later on the integration is done with respect to x. So in a case of constant limits also, the integration shall be done in the similar manner. The very first example wherein we will be asked to simplify by using change of order of integration, COI, means change of order of integration. Now in objective type of question, if this is so, we will not be interested in obtaining the complete integral, only we will be interested in interpreting the region, and now what will be the new limits. So always you focus on understanding or drawing the region first, and then appropriately to get the new limits. How the new limits will be generated? Just by reversing or swapping the uh, it will just be obtained by swapping the, we will be trying to simplify and get the answer. So this first question is evaluate integral 0 to a integral y to a x upon x square plus y square dx dy by change of order of integration. Now these limits appear in y, means they shall represent variable x. So automatically this particular limits will be for variable y. If these limits are for x, we have the horizontal strip drawn which is parallel to x-axis initially, but I am interested in changing the order of integration, so I will be drawing the region and getting the vertical strip directly so as to get the new limits, and then y which appears here in the form of constant will be converted to variable, and x which appears here in the form of variable will convert to constant. So after looking at the limits, I interpret it as the given limits are x from y to a, y from 0 to a, where x is variable and y is constant. The region of integration is as shown. This is a familiar one. X is equal to y is a line which passes through origin. X is equal to a is a line which intersects the x-axis parallel to y-axis. Y is equal to 0 is the x-axis, and y is equal to a is a line which is parallel to x-axis intersecting y-axis. So I told you ये सारा रीजन जो कॉमन होता है क्यूमुलेटिव मर्ज या ओवरलैपिंग, दैट इज व्हाट इज टू बी कंसिडर्ड एज द रीजन ऑफ इंटीग्रेशन, right? So accordingly this is particularly identified as region of integration. And as I told you, for changing the order of integration we should draw the new limits, new vertical strip, and get the limits directly. So instead of horizontal, because this represents the horizontal strip, this represents the vertical strip, so directly I will be drawing the vertical strip in the region and getting the new limits, and then our integration will be a very simple task. So after changing the order of integration, the new variable limits for y will be there, and constant limits for x are obtained. Now what are the variable limits for y? Lower end of the strip lies on y is equal to 0, upper end of the strip lies on y is equal to x. If you slide or roll this particular strip from this point to this point, x is moving from 0 to x is moving from a. So we get the limits for y as 0 to x, for x as 0 to a. So accordingly, initially variable limits were for x, but now constant limits appear for x, and hence the integration will be done. So this complete integrand is now converted to integral 0 to a, x from 0 to a, y from 0 to x upon x square plus y square dx dy. So accordingly we will be simplifying and getting down the answer. So initially the integration will be done with respect to y. X is treated as constant, so it can be compared with 1 upon x square plus a square. So I have written the formula. What is integration of dx upon x square plus a square? 1 by a tan inverse of x by a. So here x is a variable, y will be treated like a, so it will be, sorry, we are integrating with respect to y, so that means x will be treated as constant like a. Here I have written x is constant in our case. Whenever you have integral dx upon x square plus a square, it is 1 by a tan inverse of x by a. X is constant in our case, so it will be 1 upon y square plus x square into 1 by x, because a is nothing but your x. So x is kept outside. Integration of dy upon x square plus y square is 1 by x tan inverse of y by x. Limits are to be put between 0 to x, because whatever will be the variable limits. So y is our constant, sorry, x is our constant which can be compared with a. So it is 1 by x tan inverse of y by x, 0 to x. Put upper limit as x tan inverse of 1 minus tan inverse of 0. अपने लिए y वेरिएबल है और x कांस्टेंट है, इसीलिए 1 by x tan inverse of y by. Put the limit in place of y, simplify, your answer will be constant. Integration of dx is x. Put the limit 0 to a, upper limit minus lower limit, you get the answer as pi a by 4. The next example, integral 0 to infinity 0 to x, x into e to the power minus x square by y dx dy by change of order of integration. These limits are appearing in x, means those represent y. Automatically the other pair of limit will represent x. The region of integration is as shown. X is equal to 0 to x is equal to infinity. X is equal to 0 to infinity यानी ये वाला सब रीजन रहेगा. Y is equal to 0 means x axis, तो ये वाला रीजन रहेगा. ठीक है सब. एंड y इक्वल टू x यानी ये लाइन आ गया, so यहां से रीजन रहेगा. So automatically this portion is never taken into account because it is not getting merged or overlapped anywhere, right? So because y equal to x comes in between because it passes through origin. So यहां से इसका स्टार्टिंग है, तो जहां पर सारा रीजन का मर्जिंग या इंटीग्रेशन या ओवरलैपिंग होता है, that only is the region which is to be considered, right? So we have to literally leave this particular part because it is not getting covered by the boundaries whatever are provided. So accordingly we will be not having the integration to be done in that case, and we cannot simplify it further. So ultimately whatever it will be the equation y is equal to x over here, the region of integration is as shown in the figure. Now initially dekho, these are the limits for y, means vertical strip must have been drawn. So for getting the new limits of integration, I will draw the horizontal strip. Horizontal strip means it is the strip which is parallel to x-axis, and now we will be having the variable limits for x and constant limits for y. So appropriately we do the simplification. So the region of integration is as shown. By changing the order of integration, we get variable limits for x and constant limits for y. So constant limits for y and variable limits for x. So x is moving from y और आगे कहां तक जाएगा नहीं पता. So y to infinity. Slide this particular strip या roll this particular strip. It starts from y is equal to 0. यहां से स्लाइड होते होते ये लाइन से अकॉर्डिंगली जाएगा, कहां तक पता नहीं. तो y is equal to 0 to infinity. So initially the limits position was different, and now we have swapped it, and that is what the change of order of integration is. Now this particular integral transforms into this. Now variable limits are for x, so integration will be done first with respect to x. Now while doing the integration with respect to x, here product है, Liet rule के लिए this particular function should be certain variable. We call it as x square by y is equal to t. 2x dx upon y is equal to dt. Y constant है, इसीलिए that will be carried forward. Now change the limits appropriately. You get the simplification. Y will be taken outside. Integration of e to the power minus t. See, after conversion it is y by 2 dt. The limits are y to infinity e to the power minus t. Y को बाहर लेंगे, 2 भी बाहर हो गया. Integration of e to the power minus t is e to the power minus t upon minus 1. Put the limit. You get the answer in the form of y. Integrate with respect to y. Liet rule. Put the limit. You get the answer. Intentionally I have not taken minus, because minus, if it is remaining as it is, one of the pair of limit says the limit of integration or upper bound is infinity, right? And we know that e to the power minus infinity is always 0. So therefore we will be usually keeping the negative sign as it is, because while putting the upper limit as infinity, we get e to the power minus infinity as 0. Moreover, whenever you will be having one of the pair as infinity, or one of the value of the upper limit or the lower limit as infinity, whatever substitution you do, the converted variable or the transformed variable will also tend to infinity. अगर x is equal to infinity है या x tending to infinity है, तो whatever is the other substitution done, वो भी infinity जाएगा, वो कभी फाइनाइट नहीं हो सकता, क्योंकि इंफिनिटी इज नेवर सीन और नेवर नोन क्वांटिटी, राइट? तो अकॉर्डिंगली for sure, whenever there is one of the limit as infinity, after substitution or transformation of the variable also, it is still going to tend to infinity. यानी at the end there has to be one of the bound as infinity which is to be substituted, and for us, if it is having a negative index for the exponential term, e to the power minus infinity is 0. So it will be very easy for us for the evaluation or the calculation. So in this way, we try to integrate first by applying integration by parts, substitute the value, you get the answer for y, integrate with respect to y, and get the answer finite value in the